Hi, I'm Cameron McKenzie. I'm the editor-in-chief over at theserverside.com, and I wanted to talk to you a little bit about how to take a simple Spring Boot application, and really any Java application for that matter, package it in an executable jar file and move it into Docker. And if you're a Java developer, especially an old school enterprise Java developer like me, this is a quick tutorial that you got to look at. So I've got a basic Ubuntu image here. This is Cuttlefish. I just downloaded it from the Ubuntu site. I started it up in the virtual machine, and all I did was install Notepad++ and just set up a couple of URLs here. This is my GitHub repository. I'll put a link to it in the article I write about this. But I've got a repository called Spock Lizard Docker here, and it's just a basic Spring microservice application that plays a rock, paper, scissors game. If you actually looked at the code and you're a Java developer, you really wouldn't be impressed. It's got, a score class that increase wins, increase losses, increase ties. It's got a little web controller, and it's on the URL/play a game, takes the user's choice through a text field and figures out whether they tied or lost or won and returns the result. So really nothing particularly difficult or interesting in this application other than the fact that this is a typical Java web-based application developed with Spring Boot, but all the standard APIs if you look at the code. And I actually want to deploy this to Docker, show you how easy it is to make that happen. Now I do have a little install file in here, this little install mdjg file. And that is just going to install Maven, Git, Java, and Docker, all the essential things that a Java developer likes to have installed on their application. As I said, I'm just starting with a basic Ubuntu image with nothing installed other than the helpful notepad here, which I do like. And so I'll show you how you go start to finish with pulling an application and putting it into a Docker container. So I've copied this from my GitHub repository. I think there's a bunch of Windows lines in there, so you have to do a quick end of line conversion to make sure that it's Unix. I'm going to try and save that onto the desktop. Save as. Now I think that puts it into a weird desktop. Let me see. Home, Cuttlefish, desktop, and I'll call this install.sh. Save that, and let's actually take a look and see if indeed that is floating on my desktop. It is. I need to make sure that this is an executable file. Allow executing this program, and then from there I can just say, hey, let's actually run this program. Oh, and I'm not on my desktop. There we go. And this will now run. And do you want to continue? Yes, I do. And this will go forward and install those various tools: Git, Maven, Java, and Docker. Really, if you're using Docker and pulling Docker containers, you don't even need the Maven. But we're Java developers and we like to build this application from scratch, so those will be installed. I'm going to click pause and just allow all of this to run because I think everyone will be bored just watching it. And so with all those tools installed, now it's time to just do a quick check. I can do java-version. Seems like I got 11 installed. I can do Maven version. Seems like that is installed. I can do Git version, and we've got Git installed. And most importantly, Docker version, and we have Docker 18 installed. And with Git installed, I want to now bring in that application that I've got hosted over on GitHub. Pretty easy to do. Just find Spock Lizard Docker up there. That's the URL. I'll put that into the article that I write. Copy the URL here. Clone or download. That's it there. Click that button to copy. And then I'll return to my DOS prompt here. You can see it's just on the desktop there, and I'm going to do a git clone command. Git clone, paste that in. That's the URL for Git. And that will now clone the Spock Lizard Docker repository onto my file system. And with that done, I can just move into that Spock Lizard Docker directory. I have that pom.xml file in there, and since that pom is there, I can issue a Maven clean install command, and that will now build my application. Now, one of the interesting things about this application is it is a Spring Boot application, and it has there's the pom.xml file. We can prove that by looking at the fact that the parent is in fact the Spring Boot starter project. It also has an interesting plugin in it. This one here, the Spring Boot Maven plugin. That plugin, when it tells Maven that when you build the project, it should actually reach out, download a Tomcat application server, take the application that you've written, your microservice, your application, in our case it's going to be the rock, paper, scissors app, put it into Tomcat, take that deployed application that's in Tomcat, compress that all up into a jar file, and make the jar file executable. So if somebody actually just runs the jar file, it'll actually start up the Tomcat server internally and run your program locally. And that's sort of the first step in pushing something into Docker. You want to have something runnable that opens up on a port and you can communicate with. And that's what Spring is doing for us right now. Once you've got that, you can then go and run that inside of your Docker container. So let's see how the build is doing. Okay, I didn't like the first run there, but if at first you don't succeed, try again. So I'm going to try and do that Maven build one more time, see if we can pull that file down from the repo. Looks like it's working a little bit better this time. And there we go. Now we have a build success. Don't know why we had that problem last time, but we have resolved it. If I go in and actually take a look at that folder on the desktop, there's the Spock Lizard Docker. That's the repo that I pulled. There's the target folder where everything gets generated by the Maven build. You'll notice that there's a Spock Lizard jar file in there. That's the executable jar file. If I actually go in here, open in terminal, do a little ls command, you can see the Spock Lizard jar file. I can actually run that. I can go java -jar Spock Lizard 1.0.jar. Did I spell that right? Looks good. That now runs the application. You can see the console messages indicate that it's a Spring application. And if I actually go over here, open up my app, open up my browser, take a look at localhost. What port did I put it on? 8080? You'll see, hey, it starts playing the game. Which one will it be? Spock, Lizard, or Docker? I want it to be Spock. Okay, well maybe Lizard, maybe Spock, maybe Lizard. Doesn't take too long to figure out how to beat the game. But there you go, nice little web application that is now running on port 80. And again, that was all run through an embedded jar file. The whole application is embedded in that single jar file that we looked at there. I wonder if I can even just take a look at the details here. You can see that that jar file is about 17 megs in size. And there's only 6 Java files in there, so 6 Java files is probably a K. The fact that it's 17 megs, the rest of that is all Tomcat. Okay, so we've now got this application. You can see that it runs. It's a working application. You run it if you've got Java, but we want to run this assuming that we have Docker. We want this to run on any Docker installation. So I'm going to go back to the desktop. There's our Spock Lizard Docker file. You notice that in the root here, along with our pom.xml file, I've put a Docker file. I'm going to open that up with a text editor. And you notice it says a couple of things here. It says, first of all, when we run this inside Docker, we want Docker to have Java installed. And so we get this little command here. Let's pull in OpenJDK 8. That's another Docker container basically that we were going to build from as a base. That's going to give us access to the JDK in our application. We're going to create a temp directory. That's just standard. Most Unix applications look for a TMP directory, and if they don't find it, they'll fail. So just a good convention to always create a /TMP folder in your Docker Unix applications. And then what we're going to do is we're going to copy that Spock Lizard jar file that we just created. We're going to copy it from the target folder into a Docker container that's going to get created. And we're going to say, hey, when somebody runs this Docker container, what we want to do is we want to call Java, we want to run the jar file, and specifically the jar file we want to run is app.jar. And that app.jar is just Spock Lizard 1.0.jar renamed app.jar. That's just the basic Unix copy command there. Just standard that when you put your application in there, you rename it app.jar. And so that's the Docker file. And so with this and Docker installed and a Java application and an embedded jar file, all you have to do is say to Docker, hey, read this file, create a Docker container based on this information, and Docker will do that. And then all of a sudden you've got your application packaged inside of a Docker container. Well, so that's exactly what I'm going to do now. I'm going to go back here, do a little ls command, make sure I've got my Docker file there. You can see it right there. As I said, that was just downloaded as part of the repo. And what I'm going to do is I'm going to say, hey, Docker, I'll do sudo docker build. So look for that Docker file and build a Docker image named Spock Lizard, I don't know, Spock Lizard Cameron, why not? And what did I do? So let me try that again. Sudo docker build -t. Oh, you know what? Spock. I can't believe I forgot that. You always put a dot afterwards. I forgot that dot. No, don't be like me. Yeah, there's just a dot there. So it's a Spock Lizard Cameron dot. I didn't put that in the first one here, and if you don't have that, then it's not going to run. But as you can see, it's now pulling that OpenJDK image. So it says I'm downloading everything we need to have a Docker image that's got OpenJDK inside of it. That's 70 megs in size there. That's completed. It's now extracting my jar, extracting the JDK, packaging it in the jar file, and now my application is inside of a Docker image. And I can even double check that and go sudo docker images. And you can see I've got a Docker image here called Spock Lizard Cameron. You can also see that it's downloaded that Java 8 Docker image as well, right? Because I'm building on top of that. I'm taking a Docker image that's already created and leveraging the content inside of it. So now I've got a Docker image. From here, I can now run it. Right? So I just say sudo docker run -p, configure the ports. Now you remember that the original one was running on 8080. I want it to run here on 8088. That is, I want to run on 8066. Make it 80 Mario Lemieux. And really, so I want to map 8066 to 8080 on the internal port. And just say it's the Spock Lizard Cameron image I want to run. This will now kick off Docker. It'll kick off the application. And now, if I head over here, take a look at localhost, but this time instead of 8080, put it on 80 Mario Lemieux. Look at this. I'm now running my application inside of Docker. And so that's the application running inside of Docker. And if you want to, the other cool thing about Docker is of course, maybe this application gets really busy. Maybe we want to, I don't know, go in here and start another Docker container. We can do that as well. So I can say sudo docker run -p, maybe 80 Wayne Gretzky. and now this will kick off that same application. But if I go over here, type in 80 Wayne Gretzky, you'll see that the application is now running on this port. So I'm allowing Docker to just spin up image after image after image. And so there you go. I mean, that is, the essence of taking an application and putting it inside of Docker. And there's all sorts of Docker commands. You can do sudo docker ps-a, and that'll give you information about the different containers that are running in here. So you can see I've got a couple up and going. And so there's a lot more to Docker, but those are the basics. Those are the fundamentals. And if you're a Java developer, especially an old school enterprise developer who's familiar with working with tools like the WebSphere application server or Tomcat or something along those lines, and you look at something like this where all of a sudden we can just package applications in their own Tomcat server, put them in a Docker container, and then run them anywhere Docker is installed, you realize pretty quickly that Docker is really changing the game significantly in terms of how we develop and deploy applications. So anyways, that's it. That's an overview of how we work with Docker and how that is changing the deployment game. I'd encourage everybody, if you want to learn more, head over to the server side. And we're constantly running more things on Java, microservices, Docker, Git, and all those cool DevOps things that all the kids are talking about today. Thanks a lot.